So we're now going to look at another tool that is used in the description of context-free languages. So this tool that we're going to look at highlights how context-free languages are used in structured languages or are used in nested languages, as earlier on mentioned. Right, so we use the concept of parse trees, which is not generally applicable to context-free languages only, but to most fields, any structural field that you have, mathematics even, right? So that is what we're going to investigate. And we'll start by looking at its definition according to context-free languages. So a parse tree, right, is a derivation tree or a syntax tree that gives an ordered rooted tree to represent the structure of a string. Right? So in a nutshell, not using complicated words, a parse tree is there to demonstrate the derivation of an actual word, a specific word. So it boils down to having a parse tree for each word in the language described. So we end up having a parse tree for each word in the language. All right. So if you cannot generate a parse tree for a word, right, then that word is not in that language that that is in question. Right. So let's look at a language, a context-free grammar rather, given here. And in this context-free grammar, let's say we try to produce the word A, B, B, B. If I wanted to do this, what do I do? If I want to produce this word, I'm going to say S goes to SS, right? And then I'll say the first one goes to ASB. The second one, I can make it also go to ASB, right? Right, the first one, I'll terminate, put a null, right, in between for S, so this is representing null. And then I've got another S, I can put another ASB over here, and then a B. And then the next stage, I can then put a null here, I'll have A null B, A null B, B. So this is the derivation of this word. So also, it should follow that you should have a syntax tree for it, right? So we've got S over here. Where does it go to, right? So we see that this non-terminal is the parent node, and then it gives birth to SS. So SS is a breakdown of this production over here, right? So S goes to this production, which is what we saw over here. And then the first S went to ASB. Right? The second S also went to ASB. We see that here, we see that there. On this third step, this S went to a null, it terminated, and also this S went to another ASB, like that, and then eventually this S terminated into a null as well. Right, so we have a tree diagram that is describing exactly how it happened and where it happened. So now, if you draw a parse tree, right? If you draw a parse tree, you have to realize that at the end of the day, you can pass it from left to right like this. If you draw a long arrow like that, right, from left to right, will be the word that is generated by this. So when we start, we have got S non-terminal, we don't want S non-terminal, we don't want A, we put an A down. Now we put a null down. B, we move A, then we've got A, then we've got null, then we've got B, then we've got B, and we stop. So any word in a language can have a parse tree. Has a parse. This is important in showing structure, right? So we now see that this, before we get to this, we need to go through 2 implementations of S. Here we need to go through 3 implementations of S. So it is quite important to demonstrate this in a structural format, right? Because it is visually pleasing, it appears way more. This gives us what we call the leftmost derivation. So the leftmost derivation is a sentential form, right? Where you start by dealing with the leftmost non-terminals. So for example, if you are given S goes to SS, you first, the next stage, if you are not, the next stage would be to say S goes to, you deal with this S in the next step. So you have got, we did A, S, B, and this will still be an S, right? And then we are going to use this S. This is still the leftmost non-terminal, so I then come and say the next one is going to be A, now B, S. And then the next non-terminal is this S. So I've got S goes to A, now B, A, S, B. I deal with this S as well. S goes to A, now B, A, S, B, B. Then I deal with the S one more time. A, now B, A, now B, B. And then I have my word. So this is called the leftmost derivation. We start by dealing the leftmost non-terminal up until we cannot anymore. Right. And then the rightmost derivation is still the same thing, but we are starting from the right. So we can still get to the same word using the rightmost derivation. So we're going to have S goes to SS. And then we start by saying S, we have got A, S, B. And then we have S going to A, S, B, B. And then we deal with the rightmost one again, A, now B, B. Then we do the rightmost one, which is this one. We've got A, S, B, A, now B, B. And then lastly, we deal with it one more time. We've got A, now B, A, now B, B. So leftmost derivation and rightmost derivation, it does not really matter, right? It's just a matter of preference. If someone says, show me the leftmost derivation, we're giving them this. The rightmost derivation, we're giving them. Now, let's look at an example, right? So typical assignment questions come in this fashion. You are given a word and you have to test it on a range of syntax trees, right? So they're saying, is this word produced by the CFG? If so, then generate it, right? So really what you can do is you can say you start at S, and then the word starts with an A, so you need to choose A, and you need to choose S, right? And then S, it follows another A again, so we branch out with an A, then we give it an S. It follows with another A again, then we branch out with an A, we give it another S, A, and we give it an S. And then we've got another, so we're now going to have A, and we've got S. Right, now when we do this, we now have, so we do not necessarily need to use this one, so we can simply say S. We have it, we want it to terminate with an A, so we've got an A that terminates over here, therefore it terminates. When we read from left to right, we've got A, so we've got 4 A's, which is that. So this word is actually in the language, and we have given the parse tree that generates it. There is a concept that is called ambiguity. Ambiguity deals with the concept of having multiple ways of arriving at the same answer. So if I have A and I've got B, A, right? If I have got path A of getting there and path B of getting there, right? Then I have what I call ambiguous. It is ambiguous, right? So not to be confused with having this and then having A going there and having A going different paths. So this is B. This is called non-determinism, right? But then multiple path going non-determinism. Multiple path going to one destination means you have got an ambiguous problem, an ambiguous solution. So if, say, for example, you've got this language, right? You want to generate the word a, right? If we find more than one way of generating this word, then we say the language is ambiguous, right? So we'll start, we'll say, we can do the following. S goes to A, S. S goes to A, S. And then this goes to now. This is the first way, number 2. So S goes to A, S, A. And then what we have here, we also have A, S, A. And then over here we've got now. So from left to right, we're still going to have A. You're still going to have A. So we see that it is ambiguous. So we can say if a word has got more than one parse tree, then the language is ambiguous. Lastly, let's look at the concept of total tree diagram, right? So a parse tree or a tree diagram is a derivation of a word, but a total tree diagram is different in such a way that a total tree diagram gives all the words of a language as the leaves to a tree. So the terminal nodes of a total tree diagram will be all the words that are found in the language. The terminal nodes of a tree diagram will be all the words that are found in the. Everywhere where you're going to see it ends with a word, a different word. So it's actually a derivation. So you're saying S goes to AA, or you can have S goes to BX, and then what does X go to? It goes to AB or B. S goes to B, AB, or it goes to BA or BB. Right? So you can have that sort of relationship going and give you your total tree diagram. All right, so that's it. Let's meet for the next video. Goodbye.